In this lecture, we trace the polar curve r square equal to a square cos 2 theta. Let us give it equation number 1. So if you want to trace the curve r square equal to a square cos 2 theta, we check the following points. The first point is about symmetry. And if you want to check the symmetry about the polar curve, we have the three type of symmetry about the pole. So how to check the curve is symmetric about the pole? If we replace r by minus r and the equation of curve will not change, then we say that the curve is symmetric about the pole. Here, since the equation to the curve remains unchanged by changing r to minus r, because the power of r is even, which is 2, therefore if we replace r by minus r, so the equation of the curve will not change. Hence, the given curve is symmetric about the pole. The second symmetry is about the initial line theta equal to 0. How to check the symmetry about the initial line theta equal to 0? We have to replace theta by minus theta, and if the equation of curve will not change by replacing theta by minus theta, so we can say that the curve is symmetric about the initial line theta equal to 0. Now here, what is, if we replace theta by minus theta, it will become cos of minus 2 theta, and cos of minus 2 theta is cos 2 theta. Hence, the equation of curve will not change. Since the equation to the curve remains unchanged by changing theta to minus theta, so the given curve is symmetric about the initial line theta equal to 0. The third symmetry is about the line perpendicular to the initial line through the pole, that is line theta equal to pi by 2. Since the equation to the curve remains unchanged by changing theta to minus theta and r to minus r. So the given curve is symmetric about the line theta equal to pi by 2. So how to check it is symmetric about the initial line theta equal to pi by 2? We have to replace r by minus r and theta by minus theta. So if we do these two things in the given curve, equation of the curve will not change. And like that, if we replace r by minus r, so minus r square equal to a square cos 2 minus 2 theta. So minus r square is r square, a square cos minus of theta is cos theta. So we are getting the same equation. So the curve is symmetric about the initial line theta equal to pi by 2. So this curve is symmetric about all three symmetrics. Let me go ahead. What about the pole? For theta equal to pi by 4, how to check that the given curve passes through pole or not? So for any value of theta, if the value of r is 0, then we say that the curve passes through poles. Now here, if you put theta equal to pi by 4, so what will happen? It is r square equal to a square cos 2 times of pi by 4. So 2 1 ja 2 2 ja, we are getting a square cos pi by 2, and cos pi by 2 is nothing but 0, right? So for the value of theta which is substituted as pi by 4, r should be 0, so we say that the curve passes through pole. Now the second thing is, if curve passes through pole, then what is the tangent at pole? So tangent at pole can be obtained by putting r equal to 0. So let us put r equal to 0 in the equation number 1. We have r square equal to 0, which gives us a square cos 2 theta equal to 0. Since a square cannot become 0, so we have cos 2 theta equal to 0, and 2 theta equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, and so on. Right. So these are the different values for which cos 2 theta equal to 0. So what is the value of theta? Theta equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, and 9 pi by 4. So we are able to trace the infinitely many tangent at pole. But since we are tracing, we know that if we want to trace the curve, we will take the only 360-degree. So pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. It is inside the these are the less than 360. But if we take the 9 pi by 4, it is nothing but 2 pi plus pi by 4. 2 pi plus pi by 4. So this is what it is, again repeating the same angle pi by 4. So we only take this 4 pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4 as a tangent at 4. So how to draw this one? And this is pole. So this is pi by 4. This is 3 pi by 4. This is 5 pi by 4, and this is 7 pi by 4. So these are the tangent, four different tangent at pole. Let us go ahead and try to take the next point. Angle between the radius vector and tangent. So now we will take the relation tan phi is equal to r d theta dr. Differentiating one, which is r square a cos 2 theta with respect to theta, we have 2r dr d theta equal to uh, a square is a square, cos 2 theta is minus sine 2 theta, and again 2 theta is 2. Now this 2 will cancel. R dr d theta, which is equal to minus a square sine 2 theta. R dr d theta equal to r should be going this side. So minus a square sine 2 theta upon r. Now let us just reverse it. This is d theta dr. So what is d theta? This is dr d theta. So if you multiply and reverse it, so let us, if we reverse is what will happen? It is d theta dr. D theta dr is what? It is r upon minus a square sine 2 theta. And if you multiply by r, then it is r square minus a square sine 2 theta. Why? Because if you want to find the tangent, the formula for tangent is r d theta dr. Now again we know that what is the value of r square? It is nothing but uh, a square cos 2 theta. So we will put a square cos 2 theta in place of r square. The a square will cancel, and cos 2 theta upon sin 2 theta is minus cot 2 theta. So tan phi is equal to tan pi by 2 plus 2 theta. So the phi is equal to pi by 2 plus 2 theta. This is the relation between the radius vector and tangent. The point number 4 is table values. Let us try to draw some table values which correlate the values of theta and r and phi also. So if theta equal to 0, if theta equal to 0, what is the value of r? R equal to a, because cos theta is 0 means cos 0 is 1. So r square equal to a square. So r equal to a. And what is the value of phi? If theta equal to 0, then phi equal to pi by 2. Similarly, if you put theta equal to pi by 4, we have already seen that if theta equal to pi by 4, the value of r is 0, and the value of phi is pi by 2 plus pi by, uh, this is what? If again pi by 2 plus pi by 2, so pi by 2, which is equal to, which is given by pi. And if you put pi by 2, then what is the value of r? Because cos mm, cos 2 pi, if you put theta equal to pi by 2, so we are getting cos pi, and cos pi is what? It is minus 1. So r square equal to minus a square. What it means? It means that r is imaginary. And at that point, what is the tangent? So if you put here theta equal to pi by 2, so pi by 2, this is pi by 2 plus 2 times of pi by 2, 2 times of pi by 2, this 2 will cancel. We have pi by 2 plus pi, which is given by 3 pi by 2. So tangent at pi by 2 is nothing but 3 pi by 2. Let us go ahead. Reason of absence. The first point, if theta increases from theta equal to pi by 4 to 3 pi by 4, then r square remains negative. So r becomes imaginary and hence there is no part of the curve exists for theta 5 by 4 is less than theta and theta is less than 3 pi by 4. If theta increases from pi by 4 to 7 pi by 4, then again r square remains negative. So r becomes imaginary and hence there is no part of the curve exists for 5 pi by 4 less than theta and theta is less than 7 pi by 4. When theta equal to 0, r equal to plus minus a, that is, curve passes through the points a0 and minus a0. Hence, the approximate shape of the given curve is as shown in the figure. Okay, let us try to check it how we are able to trace this curve. The first point, curve passes through pole. This is the pole 0, 0, right? The curve passes through pole. And again, look here, we have already, if we put theta equal to 0, we are getting the value of r is plus minus a. That is, curve passes through the points a0 and minus a0. So the first point is a0 and minus a0. And the very important point we have already seen in the while tracing the Cartesian curve, if we are getting the pole and the two different points, so there should be loop in between these 2 points. So there is a loop over here. This is the loop, one loop over here, right? Similarly, there is another loop over here because there is again origin to a0. The first point is this. Now, second point, if you want to trace all the tangents, what are the first tangent? The first tangent is theta equal to pi by 4, theta equal to 3 pi by 4, theta equal to 5 pi by 4, theta equal to 7 pi by 4. So these are tangents. And again, at theta equal to 0, means at point A0, tangent is this, perpendicular to the initial line. Similarly, here the tangent at this is this. So now just look here how we are getting loop. This is the tangent at this point. Let me first show this part. This is the tangent. This is the tangent. And this is the tangent. So how we are able to draw the curve? So definitely we can draw like this. This is tangent. This is also tangent. And this is also, there are 3 tangent over here. So we can get a closed loop between these 3 tangent, right? And since the curve is symmetric about pole, so we can get the same type of curve in the left hand side. Again, look here, the curve is symmetric about the initial line, so we get the, if we are able to trace upper part, we have the same curve in the lower part. Again, the curve is symmetric about the line theta equal to pi by 2. So what are the curve we are getting in the right hand side? We get the same curve in the left hand side. Again, the one more thing, the first point says that if theta increases from pi by 4, this is pi by 4 to 3 pi by 4, here, this point. In this region, the value of r becomes, r square remains negative. R square negative means what? There is no part of the curve lying between theta equal to pi by 4 to theta equal to 3 pi by 4. Similarly, the theta, again r will become negative if theta lies between pi by 4 to 7 pi by 4. So just look here, there is no part of the curve in this region as well as in this region. Hence, this is the approximate shape of the given curve. Thank you.